Hello my dear students, this is Reema. So today in this session we will be doing the exercise 7.3 of triangles chapter class 9 CBSE Maths. So exercise 7.3, in the previous session I have discussed SSS congruency rule and RHS congruency rule. So this exercise problems are related to SSS and RHS congruency rule. Okay, so the first question is, triangle ABC and triangle DBC are two isosceles triangles on the same base BC and vertices A and D are on the same side of BC. That is, triangle ABC and triangle DBC are isosceles triangles. So AB is equal to AC and DB is equal to DC. Also, in the angles opposite to the isosceles triangles will be equal. So ABC angle will be equal to ACB angle, and also DBC angle will be equal to DCB angle. These two angles and these two angles will be equal. If AD is extended to intersect BC at P, AD is extended to intersect BC at P, show that. Okay, 4 questions are there, so we have to prove all these things. Okay, so we'll see how to do this. So this is our question, that is ABC is isosceles triangle, so this side will be equal, and DBC is also isosceles triangle, so these two sides will be equal. Okay, and AD is extended to B, and first one we have to prove. So what is given we will write first. Given AB equal to AC, BD equal to CD. Okay, and what these two angles are also equal. So angle ABC is equal to angle ACB. Why? It's an isosceles triangle. Also triangle DBC is isosceles. So angle DBC is equal to angle DCB. Okay, so first we have to prove what? Triangle ABD is congruent to triangle ACD. So triangle ABD and triangle ACD will be. Okay, that is ABD and triangle ACD. So we know these two sides are equal and these two sides are also equal, because these two triangles are isosceles and this is a common side. So SSS congruency rule. So we'll write that. BA equal to CA given. Okay, BD equal to CD given. AD equal to AD common side. Okay, so triangle ABD is congruent to triangle ACD by SSS congruency. Okay, first one we proved. Then the second one. Second question is, triangle ABP and triangle ABP, okay, and triangle ACP. That is ABP and triangle ACP. Okay, so let's take this triangle. These two sides are equal, and you also know BAD is equal to CAD, because in the previous question, okay, we have proved ABD is congruent to ACD. So we extend AD, then BAP is also equal to CAP because it's CPCT, and then AP is a common side. So SAS congruency rule, these two triangles are congruent. So we'll write that AB equal to AC. Why? Given angle BAP is equal to angle CAP, CPCT, okay, of the previous two triangles. Okay, and AP equal to AP, common side. Okay, so triangle ABP is congruent to triangle ACP by SAS congruency rule. Okay. Our third question is we have to prove whether AP, okay, AP bisects angle A and AP also bisects angle D. Okay, so we know that this angle, that is BAP and angle CAP are equal, right? So definitely AP bisects angle A. Also we have proved what? Okay, now we will take these two triangles. Okay, so angle, what is it? Angle BAP is equal to angle CAP, CPCT. Therefore, AP, sorry. So therefore, AP bisects angle A. BAP is equal to CAP. That is BAP is equal to CAP. So AP bisects angle A. Okay. Now let's take triangle BDP and triangle CDP. That is, let's take BDP, this triangle, and CDP, this triangle. So here these two sides are equal. Why? Because it's an isosceles triangle. And also what? And also here BP is equal to CP. Why? We have proved ABP and ACP are congruent triangles. So these two are equal by CPCT. So this is equal, this is also equal, and this is a common side. So these two triangles are congruent, and therefore these two angles, that is BDP and CDP angles, are equal. So AP also bisects angle D. Okay, we will write like this. In triangle BDP and CDP, okay, BDP and CDP, BD equal to CD given. Okay, and what? BP is equal to CP. CPCT of which triangles? CPCT of triangle ABP and triangle ACP. Okay, and then what? DP is equal to DP, that is common side. Therefore by SSS congruency rule, triangle BDP is congruent to triangle CDP. Therefore, what? B angle BDP is equal to angle CDP. Therefore, AP bisects angle D also. Okay. Now we have to prove AP is a perpendicular bisector of BC. That is AP is a perpendicular. We know that this is a bisector. Okay, so because what? BP is equal to PC. BP is equal to CP by CPCT. Now we have to prove these angles are 90. So we know, we have seen DPB and triangle DPC are congruent. So therefore these two angles are equal and they form a linear pair. Okay, we have done the similar situation before. We'll do it once again. Okay, so that is in triangle BDP and triangle BDP and triangle CDP. They are congruent. Okay. That is, they are congruent. Therefore, angle DPB is equal to angle DPC. Okay. So, angle DPB plus angle DPC is equal to 180 degree because they form a linear pair. Okay. That is, BC is a straight line. So, therefore, 2 times angle DPB is 180 degree. Angle DPB is 180 divided by 2, that is 90 degree, which is equal to angle DPC. Therefore, AP is a perpendicular bisector of BC. Now we have proved this also. So moving on to second question, that is AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. Show that AD bisects BC and AD bisects angle A. So this is our triangle, that is ABC is an isosceles triangle. Okay, so these two sides and these two angles are equal. Now AD is an altitude. Okay, altitude means what? This is 90 degree. Altitude means a perpendicular. Okay, this is 90. So AD is an altitude of altitude. Show that AD bisects. We have to let it be AD. Okay, AD is a AD is a altitude that is perpendicular to BC. And now we have to prove AD bisects BC. So BD is equal to DC, we have to prove. Also AD bisects these two angles are equal, we have to prove. So now let's take in triangle ADB and triangle ADC. These two triangles we will take and we can prove the congruence. Then all these things will be proving that. Okay, so here right angle is there, hypotenuse are equal, that is the side opposite to the right angle, that is hypotenuse are equal because this is a isosceles triangle. And now this side is common. Okay, so these two triangles are congruent, that is we'll write like this. In triangle ADB, AB equal to AC given that is angle ADB is equal to angle ADC 90 degree. AD is equal to AD, common side. Therefore, triangle ADB is congruent to triangle ADC by RHS congruence. Okay, so therefore BD is equal to CD. Okay, and therefore AD bisects BC. Okay, these two are equal, so AD bisects BC, and therefore now AD equal BC by CPCT. Also, angle BAD is equal to angle CAD by CPCT. Therefore, this is first one and this is second one. AD bisects angle A. Okay. Moving on to the third question of exercise 7.3. That is, two sides AB and BC and median AM of one triangle ABC are respectively equal to, that is AB, BC and median AM. Median means a line connecting the center of BC. Okay, BC to A, that is median. Okay, median that is AB BC and median are respectively equal to that is PQ, QR and median PN. Okay, show that triangle ABM is congruent to triangle PQN. That is triangle ABM and triangle PQN are congruent. Okay, I'm not doing this, I'll just explain. Okay, here that is in triangle ABM and in triangle PQN, it's given AB. Okay, AB and PQ is equal. Okay, also AM and PN is equal. Okay, and it's given BC is equal to QR. So BC by 2 will be equal to QR by 2. What is BC by 2? BM. And QR by 2 is QN. So all three sides are equal to the other three sides of the other triangle. Okay, so by SSS congruence rule, these two triangles are congruent. So we have proved this. So now we have to prove the congruence of triangle ABC and triangle PQR. So here also AB is equal to PQ. And in the previous triangle, angle ABM and angle PQN are equal by CPCT. So these two angles are equal by CPCT, and also BC is equal to QR. Right? It's given. So by SAS congruency rule, this is also equal. So these two triangles are congruent. Okay, so moving on to the fourth question. BE and CF are equal altitudes of triangle ABC. Using RHS congruence rule, prove that the triangle ABC is isosceles. So this is our triangle ABC and BE is altitude. Okay, that is BE is altitude, and CF, this is also altitude, the CF. Okay, that is BE is equal to CF. These two are equal. So given BE is equal to CF, and now using RHS congruency rule, prove that triangle ABC is isosceles. So now let's take these two triangles, that is triangle BFC and triangle BFC and triangle BEC. BEC. Okay. So here right triangle, that is angle F is equal to angle E is equal to 90 degree. So side opposite to the 90 degree, that is hypotenuse. BC is equal to BC, hypotenuse equal. Okay, and also it's given what BE is equal to CF. BE equal to CF. So what is there? Right angle, hypotenuse, side. So by RHS, these two triangles are congruent. Okay, BFC and BEC, that is BFC and this is congruent. So obviously these two angles, that is angle B is equal to angle C. Why? CPCT. So the sides opposite to the equal angles will be equal. That is, side opposite to angle B is AC will be equal to side opposite to angle C is AB. So therefore, AB is equal to AC. Sides opposite to equal angles are equal. So therefore, triangle ABC is isosceles. Okay, we have proved it. Our last question is, ABC is an isosceles triangle with AB equal to AC. Draw AP perpendicular to BC to show that angle B is equal to angle C. ABC is an isosceles triangle. That is, ABC is an isosceles triangle with AB equal to AC. AP is what AP is, draw AP perpendicular to BC. Okay, to show angle B equal to angle C. So now what will take triangle ABP and triangle ACP. So what, this is right angle, hypotenuse and common side. So by RHS congruency rule, these two triangles are what, are congruent. Okay, by RHS. So then angle B will be equal to angle C by CPCT. And that's all for today's session. If you have any doubt, please leave a message on the comment section. And those who are watching my videos without subscribing, please do subscribe to my videos. And also don't forget to click on the bell icon so that you'll get notified when I add a future video. So thank you.